Good morning. It's the beginning of May, the 1st of May. All of y'all are very excited. Yes. All right, so what we're going to be talking about today is series parallel circuits. So we talked about series circuits. They're the most simple case. We talked about parallel circuits. They're not too complicated, but you have to simplify them to solve them too. What we're going to be talking about today is a series parallel circuit, which is both put together. So this is when things get real. This is the way real life works. You have things that are both in series, in parallel, in the same circuit. So the first step to simplifying a series parallel circuit is to draw a schematic diagram of the circuit. This is on page 637. This is a problem-solving technique that will help you out with this. So it says draw a schematic diagram of the circuit. So as you can see here, we have a 60-volt battery connected in series with an 8 ohm resistor. And then it's connected in parallel to two other resistors, one with a resistance of 25 ohms and one with a resistance of 15 ohms. So step 2 is to find any parallel resistors. Remember that resistors in parallel have separate current paths, so a different amount of current goes through each branch. They must have the same potential difference across them, though. That means that the voltage of R2 is the same as the voltage of R3, which will help us out a lot in a minute. So calculate the single equivalent resistance of a resistor that can replace them, and then draw a new schematic using that resistor. So what they're saying is take these two circuits and get the equivalent resistance of the parallel circuit. So that'll be 1 over 25 plus 1 over 15 equals 1 over the resistance. And solve for the resistance. Remember, don't just add the fractions and call that your answer. You have to do 1 divided by whatever that answer is to get the actual resistance. So as you can see, they did step 2 right here. After they did step 2, they ended up with a series circuit again. So this has an 8 ohm resistor, and these two reduced down to a 9.4 ohm resistor. Okay? Number 3, it says, are any resistors, including the equivalent resistor, now in series? Resistors in series have one and only one current path through them. Calculate a single new equivalent resistance that can replace them, and then draw a new schematic diagram. Now remember, when we're adding resistors in series, you just add them. So the new equivalent resistance is going to be 8 plus 9.4, which is going to give us 17.4. It says repeat steps 2 and 3 until you have simplified it to just one resistor. Find the total current, then go backwards through the circuits to find the currents through and the potential differences across individual resistors. So once you get down here, you're going to work your way back up through the circuit. Okay? So that's how this works. Just if you don't draw the schematic diagrams, these problems are nearly impossible to solve. They are so much easier once you draw the diagram, so make sure that you're not skipping out on drawing the diagram. I know it seems like it's going to be tedious, but it's a lot easier to draw the diagrams than it is to just not do it and try to do everything in your head. Okay? So I have an example problem that I'd like to work out with y'all. So as we start here, we have a hair dryer with a resistance of 12 ohms and a lamp with a resistance of 125 ohms that are connected in parallel to a 125 volt source through a 1.50 ohm resistor in series. Find the current through the lamp when the hair dryer is on. Okay, so what we're going to do is we're going to start with our voltage source. We're going to pretend it's a battery, even though most likely it's not a battery. It's, your grid electrical, which is technically a different diagram, but we're not going to worry about that. So it says that I have a 1.50 ohm resistor in series. So that means that this one is 1. Come on, keep writing. There we go. 1.50 ohms. And then it says that we have a resistor in parallel. And this is going to be for the lamp, so it's 12.0 ohms. And it says there's another resistor in parallel, and this is going to be the hair dryer. And the hair dryer has a resistance of 125 ohms. This guy over here is 125 volts, We know that positive is the top, negative is the bottom. Okay, so it wants me to find the current that goes through the lamp. The lamp is right here. So you see that we have a series parallel circuit, correct? It's combined. Okay. So step one was to do what? Okay, we'll go back. Step one was draw the schematic. We did that, right? Step two is to find the parallel resistors and combine them. So we come over here, and we are going to change this circuit into something that looks like this. What I typically do is I do all the drawings first, and then I do calculations, just because I think it's easier that way. So this is going to be the 1.50 ohms. This one I'm going to label as R sub P for parallel. And this is still 125 volts. And then the last one that I'm going to do is 125 volts. I'm going to call this R sub S for series. Okay, so I need to figure out what RP is. So the way that this equation works, it's 1 over RP is equal to 1 over 12.0 plus 1 over 125. Okay? So if I look right here, can y'all immediately think of a common denominator between 12 and 125? No. But what do y'all have as a tool that you can use? A calculator. So what we can do is instead of trying to figure out common denominators to add our fractions, we're going to go to our calculator. So I can do 1 divided by 12 plus 1 divided by 125 equals. So I got this weird fraction, or this weird decimal, right? Is this my answer? No, I have to do 1 divided by that answer. So if your calculator has a button that looks like this, you can use it. If you're using the calculators that I have, you just hit 1 divided by answer, right? So I'm going to hit this, which is just doing the reciprocal, 1 divided by. And we see that RP is going to equal 10.9489 ohms. I'm going to keep it as long as I can, 10.9489 for now, just so that I don't introduce too much rounding error. 9489. Okay, well, when I come here to do this one and calculate RS, it's going to be 1.50 plus whatever our parallel was. So it'll be 10.50 plus, or 1.50 plus 10.9489, which will give us, coming back to the calculator, just add 1.5. 12.4489. Okay. So my goal is to find the current going through this 12 ohm resistor, right? That's the goal. Well, to do that, I need to find the current through the whole thing. And then I can come up here and I can figure out what the voltage of RP is. If I know the voltage of RP, I know the voltage going through this resistor, and I know the voltage going through this resistor, right? Okay, so now we're just going to work backwards. So if I know this resistance and I know this current, I can solve for I for the circuit, right? I for the circuit is equal to V over R. That's one of Ohm's 3 laws. Remember, we had V equals I times R, I equals V over R, and R equals V over I. So to get I, excuse me, we'll do 125 divided by 12.4489. Okay? So come back over to the calculator. I'm gonna do some magic on this calculator because I can't just store. Well, I guess I could. So I'll hit memory store. Okay, so 125 divided by, and then I'll recall that number. Boom. We get 10.04 amperes. Okay, so that means that I that's going through here is going to be 10.04 amperes. Okay? Well, this is still that same series, right? So that means that I going through here is equal to what? Okay? So if the I is 10.04, and I know the R, can I calculate the V? Okay? So the voltage for the parallel part is equal to I times R. So the voltage for the parallel part is going to be 10.04 times that 10.9489. Now, if you've got the calculators for my room, you know that you can carry out all the sig figs and use this full number, right? The reason I kept 4 decimal places is I know I'm going to round to 3 at the very end, 3 sig figs. So I'm not going to introduce too much rounding error. Okay? So I got this number times 10.9489. And I get that V parallel is going to be 109.9384. Okay? All right, so I come all the way back over here. And that shows me that this voltage right here is going to be equal to 109.9384. Okay? And if this part of the parallel circuit has 109 volts, this side over here is also going to have okay? Remember, if you have a parallel path, both of those paths have the same voltage. Okay? So I need to figure out the I for the lamp, which is this guy right here, right? So what's the Ohm's law for I? I equals V over R. So I for the lamp is equal to the voltage, which was 109.9384, divided by the resistance of the lamp, which was 12.0, and we will get our final answer. So we divide it by 12. We get 9.1615, all that stuff. 9.1615. How many sig figs did I have? 3. So I can round my final answer. I for the lamp is equal to 9.16. Unit for current is A for amperes. Okay. It would also be trivial if they had asked me to do this one over here, right? I just do the same thing. I equals V over R. And I can figure out the current here. What's the current through the first resistor? 10.04 amps. Okay? Remember, follow the current paths. So if I have the I going this way and the I going this way, these two numbers are going to add up to be 10.04. I didn't create any new current when I made these branches. I just had some of the current flow this way and some of it flow that way. Okay, so that is how you combine and break these circuits down and solve. As long as you are keeping yourself organized, drawing your pictures, leaving yourself space, these problems won't be that difficult. If you don't draw your diagram, if you're very unorganized, then you're going to have a problem. Okay? All right. Your homework today is going to be chapter 23, number 25 through 30. So it's only 5 for 6 problems. They shouldn't take you too awful long. I'd like you to go ahead and get started on that. Have a wonderful day.